Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about the loan default prediction problem. Even before I proceed to demonstrate, how do you predict loan defaulters by building a decision tree model using SPSS? May I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing to my audience the data set that I'll be using for today's video. I've got historical data of customers. You can see here, there are variables like age, education level, number of years with the current employer, number of years in the current address, income level, debt to income ratio, credit card debt measured in thousands. Then the last two variables are other debt and the variable default. The last variable default will be used as the dependent variable. The rest of the variables will be used as independent variables. I've got a healthy sample size of 850 records, and I have approximately 10 variables in this data set. With this introduction about the data, let's now proceed to develop a decision tree model in SPSS. As you can see, this is my SPSS application. It is showing a blank screen because I have not loaded the dataset. Let me go ahead and load the bank loan dataset. I'll be going to the File menu bar, Recently Used Data. SPSS shows 10 recently used datasets. I'll be using the dataset bank loan, which is the first file. Let me go ahead and select this particular data. You can see here the dataset gets loaded into SPSS. What you're seeing here is the details of the first customer. The first customer, his age is 41 years. His education is some college. Number of years that he has spent with the current employer is 17. He's been living in the current address for 12 years. The income level is 176. Then you have another variable, which is debt to income ratio. The next variable that you have is credit card debt in 1000. The most important variable here would be default. Let us look at the coding for this particular variable. As you can see here, it says 1 for those people who have defaulted and 0 for those people who have not defaulted. The last three variables are not useful. So let me select the last three variables, right click and remove these last three variables. Now, one of the first thing that I would like to do is look at the distribution of my dependent variable. This is done to identify if there is a class imbalance issue. What do I mean by class imbalance? As you are aware, we are interested in identifying the behavior of defaulters. In a typical banking scenario, the proportion of defaulters will be less than 1%, and the proportion of non-defaulters will be 99%. Since the proportion of defaulters is very low as compared to their counterparts, this results in what is called as class imbalance issue. Now, why should you worry about class imbalance issue? You should worry about class imbalance issue simply because when there is class imbalance in the dataset, the model will learn the behavior of the dominant class or the majority class, and it will do a very poor job of classifying defaulters. This is where a simple pie chart would help us. Let me go to the Analyze menu bar. What you see here is all the options that allows you to analyze the dataset. I'll be going to descriptive statistics, and then I'll choose frequencies. You can see here, this opens up a new dialog box for frequencies. I've got all the variables to the canvas in the canvas to the left-hand side. I'll choose the last variable previously defaulted and hit the arrow here. In the right-hand side, you have what is called as the charts option. Let me go ahead and click on charts. Here, there are 4 options. By default, it is none. You can choose to create either a bar chart, pie chart, or a histogram. I will go ahead and select the pie chart. Let me also select percentages, hit the continue button. I'll again go ahead and select the OK option here. What you're seeing here is the output window of SPSS. Let me scroll down. This is the pie chart which gives us the distribution of defaulters. The blue slice, which is the dominant slice, indicates the proportion of non-defaulters. However, I'm interested in the red slice, which indicates the proportion of defaulters. Roughly 3/4 of the slice is covered by non-defaulters, 1/4 by defaulters. So I'm assuming that the percentage of defaulters would be 25%. If you want to display a precise number, you can go ahead and double click on the pie chart. This will activate what is called as the chart editor window. Here you have a very interesting option which is called as data label mode. Let me select this and click on each of the slices. Let me go ahead and close the window here. You can see here the proportion of defaulters is 26%, which is good enough for us to build a basic model. With this preliminary check, let me now proceed to building a CART model. What is CART? CART stands for classification and regression tree. To build a classification and regression tree, let's go to the Analyze menu bar. Here you have the Classify option. The moment I hover the mouse on top of Classify, SPSS displays 7 options that are present for classifying the data. Let me choose the first option from the top, which is called as the tree option. Let me select this option. As you can see, this opens up a new dialog box, which is called as the decision tree dialog box. In the left-hand side, you have all the variables that are present in the data set. And in the right-hand side, you have 2 options. One is what is called as dependent variable, and the second is independent variable. For those of you who are very new to a decision tree model, there are 5 important points that you need to keep in mind. A decision tree model is a supervised machine learning technique, which means that in a decision tree model, you need to specify the dependent variable. Number 2, a decision tree model can handle mixed data type, which means you can specify both scale as well as categorical variables. Number 3, a decision tree is a non-parametric approach towards model building. We are not making any assumptions about the distribution of the data. Number 4, in a decision tree model, typically what we have is a problem which is called as overfitting problem. To address the problem of overfitting, people tend to use a random forest after building a decision tree model. The 5th point here is that a decision tree is a rule-based approach. It is very, very simple and easy to understand as compared to some of the more complicated techniques like logistic regression model. With this understanding, let's go on to specify the dependent variable as well as the independent variable. The last variable previously defaulted will be my dependent variable. The rest of the variables will be independent variables. As you can see here, SPSS provides 4 options. I like to draw your attention to what is called as the growing method. Let me click on the drop-down menu. You can see here, there are four algorithms that are present, sorry. One is what is called as CHAID algorithm, which stands for chi-square automatic interaction detection. The second one is what is called as exhaustive CHAID, which is a different flavor of the CHAID algorithm itself. The third algorithm here is CRT, or classification and regression tree. And the last of the options here is QUEST model, which is called as quick unbiased estimated statistical tree. I will choose the third option, namely CART option. You can go ahead and click on the OK button, in which case you'll be building a basic decision tree. One of the important points to remember when you build a CART model is that it will be using what is called as a Gini's coefficient. It results in binary splits. At the right-hand side top corner, you have 5 different options. Right at the top, you have what is called as the output node. My apologies, this is called as the output tab. Let me go ahead and click on the output tab. This will produce a new dialog box, which is called as the output dialog box. You can change the orientation of the graph here. I will ignore this. Let me click on statistics. And below, I'll choose importance to the model. What does this give you? This will give you the variable importance for each of the independent variables. You have plots. I'll choose independent variable importance to model. Last but not the least, you can go ahead and choose what is called as rules. This will generate classification rules. You can get the syntax either as SPSS statistics or SQL or in the form of simple text. I will choose simple text and then select export rules to a file. You can go to browse, and at the desktop, you can give a name which is called as test file. Let me go ahead and save the rules as a simple notepad file. Let me hit the continue button. Next, we have what is called as validation. Let me go ahead and click on validation tab. This will give you 2 or 3 very important options. I like to choose cross validation. You can see here the default number is 10. I like to change this to 5, which results in a 5-fold cross validation. If you choose to split the data set in a different proportion, let us say you want to choose 70% for training and 30% for test, you can use the option case allocation. Here you have 2 important options, which is display results for only the training and the test sample, or, my apologies, the first option, that is training and test, will display the results for both training data as well as test. If you choose the second option, the algorithm will display the results only for the test sample. I don't want to split the data based on train test. So what I like to do is perform the cross validation option. Let me now go to the continue button here. You have criteria. The default number of cases here under the parent node will be 100. This is the minimum number of cases. The minimum number of cases for the child node will be 50. You have the option cart here. You can look at 2 options under the impurity measure. The default option for cart is Gini's coefficient. SPSS gives you a small description under Gini, which is to say the splits are found that maximize the homogeneity of the child nodes with respect to the value of the target variable. You can experiment either with a Gini's coefficient. You can also try what is called as towing. In the case of towing, what happens is the categories of the dependent variable are grouped into 2 subclasses. The splits are found that best separate the 2 groups. The dependent variable, if The nature of the dependent variable is a ordinal variable. You can choose the last option, that is ordered towing. For all practical purposes, Gini's coefficient is a good measure, so I'll retain the option Gini's coefficient. Let's click on continue. You have the option save. You can click on the terminal node number, the predicted value, and the predicted probabilities. The terminal node number does not help us much. It just tells us based on which rule a particular person or a customer has been classified into which category. You can hit the continue button and then go to options tab. Here you have multiple options like misclassification cost, profit, prior probabilities, so on and so forth. I like to ignore these options as of now. Hit the continue button, and then once you're sure with the options that you have specified, you can go ahead and hit the OK button. SPSS takes barely 15 seconds to run the model. You can see here, this is the output of the classification tree. You're getting a table for the model summary. This gives you basic description of the algorithm. You can look at the tree diagram. For better visibility, let me double click on the tree diagram. Increase the zoom percentage to 200%. Here, our decision tree is ready. What you're seeing right at the top is the distribution of the dependent variable. It's also called as the parent node. As you can see here, SPSS has highlighted the no category using red and the yes category with blue. Yes represents defaulters, no represents non-defaulters. As we have seen earlier, the proportion of defaulters is 26%. SPSS highlights the majority class. Since the majority class is no, SPSS has highlighted the non-defaulters. This node is called as the parent node. Next, we can look at the most important variable. Right below the dependent variable, you have a variable which is called as debt to income ratio. I repeat, this is called as debt to income ratio. The improvement here is 0.049. This is the most important variable out of all the variables, and therefore debt to income is chosen as the best predictor. The decision tree splits into two parts based on the debt to income ratio of a customer. If the debt to income ratio of the customer is greater than 14.7, the majority class is defaulters. You can clearly see here 55% of them tend to be defaulters when the debt to income ratio exceeds 14.7. This is also called as terminal node because below this particular node, you don't see any other variable. On the left-hand side, you see debt to income ratio less than 14.7. In this case, the majority class is non-defaulters. Here, the proportion of non-defaulters is 82%. Let me scroll down. When the debt to income ratio is less than 14.7 and years with the current employer, here again you can see there's a split. When the years with the current employer is greater than 4.5, the majority class is non-defaulters. What happens when the years with the current employer that the customer has spent is less than 4.5? The majority class here is non-defaulters. Let me scroll further down. You can see age of the customer is the last variable that is used to build the model. Here again, there are binary splits. You can see when the age of the customer is greater than 32.5, 84% of them are non-defaulters. When the age of the customer is less than 32 years, 56% of them are non-defaulters. As you can see, this is a very, very simple and easy to understand graphical display, which even non-statisticians and non-technical people can go ahead and implement. This is why we say decision tree is a rule-based approach, and it is a very, very simple algorithm which anybody can go ahead and use. There are a couple of options which allows you to change the orientation. You can see here right now, the option is top down. The orientation that we have chosen is top down. You can choose other options like orient left to right. You can see here the display changes. You have another option which is right to left. You can also change the display of the graph. You can see here, I'll first of all go to top-down approach. There are three interesting options here. Show tables in the tree nodes, which is what is the default option. The second one is show charts in the tree node. You can see here, within the box, you can see a bar chart is being produced. This is shown for all the independent variables as well. The last of the options that you have here is to show tables and charts in the graphical display. If you choose the last of the options, what SPSS does is it just gives you a numerical summary. Below the numerical summary, it produces a bar chart. I'll go ahead with the first option, close the tree diagram. When we build a model, we are curious to understand what is the performance of the model. Let me go ahead and look at the risk statistic. You can look at the risk statistic here. Under the resubstitution method, it is 0.239. And under the cross-validation approach, it is 0.264. More than the risk statistic, typically, we look at what is called as confusion matrix. The confusion matrix is widely used to assess the performance of the model. Along the row, you have the distribution of the actual category, that is no versus yes. SPSS calls this as observed category. And along the column, you have the distribution of the predicted class. Predicted by whom? Predicted by the cart model that we have built. Typically, the numbers along the diagonal represent the correct classification, and the numbers along the off diagonal represent misclassification. So 446 and 87 are the correct classification. Why? Simply because there are 446 non-defaulters whom the model has correctly predicted. Similarly, 87 defaulters have been correctly predicted. The rest of the numbers, that is 96 and 71, are misclassification. When you want to study the overall percentage, have a look at this number, 86.3. What does that tell you? The row here is no, which means that the percentage of correct classification for non-defaulters is 86%. The percentage of correct classification for defaulters is 48%. And the overall percentage of accuracy of the model is 76 here. 76 is a good number. However, the fact that our model has predicted only 47% of the defaulters correct is a cause of worry. Let's now proceed to look at the independent variable importance table. Here you can see SPSS prints three columns. One is the independent variable list. Then you have the importance and the normalized importance. The most important variable here is debt to income ratio. Its importance value is 0.049. The second most important variable here is years with current employer, and the third is age in years. The least important variable is level of education. We also have other debt in 1000. Household income in 1000 doesn't seem to predict the outcome variable. If you're finding this difficult to understand, you can look at the bar chart here, which is the importance chart for each and every variable. You can have a look at it. Debt to income ratio, years with a current employer, and age are the three most important variable. The last three, that is household income, other debt, and level of education, are not so important. I'd like to draw your attention to two important aspects. At the top, what you're seeing is normalized importance. It sums to 100%. And at the bottom, what you're seeing is the importance value. Let's now proceed to look at the data set. This is my original data set. You can see SPSS has created 4 new columns. The first column is node ID, which means the node based on which the decision has been taken. Then you have the predicted value, predicted probability for the first group, and predicted probability for the second group. You can see here, when you compare 0.91 with that of 0.09, clearly 0.91 is a bigger number. Since there is a 91% chance of the first customer being a non-defaulter, the model has classified him as a non-defaulter. But when you compare the predicted value and the defaulted, the actual category, there is clearly a misclassification. Let me go ahead and delete this particular column, node ID. You can compare the two values. The actual category is 1, the predicted is 0, which is clearly a misclassification. Let's now look at the second customer whose actual class is 0, but the model has predicted the class as 1, which is again a misclassification. When you look at the third case, the actual group is 0. The predicted group is also 0, which is the correct classification. The fourth category is also correctly predicted. When you look at the fifth case, here we have a defaulter. The model has predicted him as a defaulter. The predicted probability for group 1 is 45%, and the predicted probability for group 2 is 55%. If you want to sort the customers based on the highest predicted probability, you can select the second column, right-click, and simply say sort descending. As you can see here, the highest predicted probability is 0.55. Let me now proceed to show you the text file which we have saved in the desktop. This text file would show us the rules which have been used to classify each and every individual. As you can see here, this is the text file which I had saved, test file. This represents node 5. You can see there are if-then conditions here. If these conditions are satisfied, the model will put him in a category which is called as node 5, and it will predict the category, the customer, as 0 or as non-defaulters. The predicted probability here is 56%. Like this, you have the rules for node number 6. Node number 6, when we scroll down, is again a set of rules which is going to predict the customer as belonging to the non-defaulter category. I'm just interested in looking at the rules for defaulters. You can see here, node number 4 is going to predict the customer as 0. What is interesting here is node 2 has a set of if-then condition which is going to predict the customer as a defaulter. The predicted probability here is 55%. We can experiment with other algorithms as well, because the overall accuracy was very low for defaulters. With this, I have come to the end of today's video. In today's video, we've seen how to build a decision tree model to identify the profile of defaulters. We have seen the interpretation of a tree diagram. We have seen the output of five-fold cross-validation. We have seen importance chart. And last but not the least, we have seen how to extract the rules from the decision tree. Thank you very much for watching this particular video. Have a great day ahead.